Quiz 6, question 4. A 1.8 kilogram object is moving at 1.2 meters per second. A 4.4 Newton force is applied in the direction of the motion and then removed after the object has traveled an additional 9.6 meters. How much work was done on this object? So, once again, let's draw this out. We have an object, and we'll have a box. Alright, and the distance this box travels will be from here and 9.6 meters to somewhere, let's say over here. And the box will be here. Alright, so let's write out what we know from the question. We have a mass of 1.8 kilograms. We have an initial velocity of 1.2 meters per second. We have a force of 4.4 newtons. And we have a change in distance of 9.6 meters. And we do not have any friction. Alright, so how much work was done? Well, there's a lot of information in this question that we don't even need, because the formula for work equals force times the change in distance times the cosine. Alright, and we don't care how fast it's moving. And since there's no friction, we don't have a force in the opposite direction. Gravity is not going to be doing anything to us because there's normal force to cancel that out. So the only force that we are worried about is the force that goes this way, which is given in the problem. So we can just work this out. So the force would be force times, well, it would be 4.4 newtons times the change in distance, which is 9.6 meters. And the cosine is going to be 0, but we can add it anyway. And cosine of 0 is 1, so and then so the work done will be 4.4 times 9.6 times the cosine of 0, which gives us work done was 42.24 joules. Now, if we were using the kinematic equations, we might care about velocity and some of these other numbers, but when we're just calculating work, we don't care. We just need the force, change in distance, and the cosine.